In sections 8.2 and 8.3, our goal is to be able to verify characteristics of parallelograms and use properties of parallelograms to solve problems. Let's begin with the definition of a parallelogram. It is a quadrilateral, 4 sides, with both pairs of opposite sides parallel. So make yourself a picture of what that looks like. This side and this side parallel. Remember how we show that with the arrows. The other pair of sides parallel. Remember how we show that with the arrows. If both pairs of opposite sides are parallel, that is the definition. It is a parallelogram. Parallelogram. Now from there, we have properties. The properties will always hold true if we know that we have both pairs of opposite sides parallel, such as both pairs of opposite sides will be congruent. So these sides across from each other congruent, these sides across from each other congruent. Same size. And then a combination of the parallel and congruent. One pair of opposite sides will be both parallel and congruent. So if all we know is about one pair of sides, it must be parallel and congruent. Both of those. If I don't know anything about the other sides, it must be that. Can you imagine parallel but not congruent? So these are going in the same direction, but if I make one short and one long, does that look like a parallelogram now? No, it doesn't. So one pair of sides must be parallel and congruent. Both pairs of opposite angles are congruent. Opposite angles, such as P and R, those are the same size. Notice how they're both acute in this picture. Angles Q and S, opposite from each other, those are congruent. Notice how they're both obtuse in this picture. Consecutive. Consecutive means next to each other. Consecutive angles are supplementary. What does that mean? Their sum is 180 degrees. So for example, if this angle is 100 degrees, the one next to it must be 80 degrees. So that these two next to each other, or consecutive, must add up to 180 degrees. But next to in any direction. So next to the 100-degree angle here must be 80 degrees also, because these two have to add up to 180 degrees. Any two angles next to each other. Finally, the diagonals bisect each other. Here's a diagonal, here's another diagonal. Remember that bi means two and sect means cut. So cut into two congruent parts. This diagonal will be cut in half, this diagonal will be cut in half. Let's practice using these properties. Decide whether the figure is a parallelogram. Explain why or why not. I'd like you to look at the first two pictures together. Picture 1 and picture 2. Look at these two diagrams. I see parallel, I see parallel. One of these, however, is not a parallelogram. Can you think of which one? If you said the first one is not a parallelogram, you would be correct. This one, not a parallelogram. Why? I only see one pair of opposite sides parallel when I remember that I'm supposed to see both pairs of opposite sides parallel. Here I see a pair of opposite sides that are parallel and another pair of opposite sides that are parallel. So this one is yes, because both pairs of opposite sides are parallel, and we do need that explanation. You need to know how to recite that explanation, versus this one is not, because only one pair of opposite sides is parallel. Let's look at another pair of pictures that look very similar in how they're labeled. Number 3 and 4. Look at those two pictures. I see in number 3 that these opposite sides are congruent. That's congruent. And these opposite sides are parallel. But if we go back to our list of properties, is there a property that says one pair of opposite sides is congruent and one pair is parallel? Well, we have both pairs of opposite sides are congruent. If we combine congruent with parallel, then it needs to look like this, where it's the same pair of opposite sides that is both congruent and parallel. What is that? Where is that demonstrated? Here in number 4. This one follows that property where one pair of opposite sides, one pair of opposite sides is both congruent and parallel. In this picture, that is not the case. The pair of sides that is congruent is not the pair of sides that is parallel. So in this case, it's not the same pair of opposite sides that are congruent and parallel. Must be the same pair. Let's look at another pair of pictures, numbers 5 and 6, and talk about what we see here. I see congruent marks in this picture. I see congruent marks in this picture. Now, if you go back and you look at the properties that we listed, both of these are illustrated. But what can be tricky here is how to describe what you see. Here, it's the sides that have the congruent marks. So this one talks about the sides, both pairs of opposite sides are congruent because of the hash marks. These have hash marks on the diagonals, not the sides. So this one is the property about how the diagonals bisect each other. Notice the difference in where the congruent marks are on the diagonals for this one, on the sides for this one. These are on the sides, not the diagonals. Let's look at one last pair of pictures, number 7 and number 8. What do I see here are angle measures. Specifically, I'm going to look at the two angle measures that are next to each other, since I don't have all of the opposite angle measures, but I do have these two. Remember that the angles next to each other, if I add them up, are supposed to add up to 180 degrees. Is that what these do here? Nope, 181. So this one's a no, because the consecutive angles are not supplementary. So we're going to write that the consecutive angles are not supplementary. How about here? Well, I notice these two angles, when I add those up, make 180 degrees. But be careful that we find out if all of the consecutive angles add up to 180 degrees. So not only will I add those two up, but also I'm going to add those two up, 120 and 60, another 180 degrees. So I do see that, yes, because the consecutive angles are supplementary. So let's just take a moment and think back to our objective. Are we feeling a little bit more comfortable identifying properties of parallelograms? That's what you want to think about at this point. If you're not, maybe you take a moment, rewind the video, and watch some of these examples again. If you are, let's move on. Now we're going to put this into practice and use the properties of parallelograms to solve problems. Examples. Find the value of each variable in the parallelogram. So let's think about where the variable is in this first one. I see an x and it's labeling this side. How do I know it's labeling the side? It's outside of the parallelogram. It doesn't have a degrees symbol like these do right here. When I think about sides and parallelograms, I think about, well, first, the sides are parallel. Okay, so opposite sides are parallel. What else do I think about sides? Opposite sides are congruent. Well, with measures and values, the most helpful one that's for solving these problems is going to be that opposite sides are congruent. Both of these facts are true, but this is going to be the useful one to us. So that means I can put a little hash mark on this side and a little hash mark on this side to tell me this measurement and this measurement are supposed to be the same. So I will make an equation that 3x plus 4 must equal 16, and I can solve that equation. So we subtract 4, 3x equals 12, so x must equal 4. How about the y that's in that picture? Well, where is the y that's in that picture? I see a degrees and I see it's inside of the parallelogram, so it's telling me that it's for this angle that's right here. The 56 is telling me for this angle that's right here, 56 degrees. Well, if I think about angles in a parallelogram, what do I know about the angles? Specifically, the ones across from each other. Those are called opposite angles. Well, I look back at my properties and I see that opposite angles are supposed to be congruent. That's going to help us here. So I'm going to say that y minus 60 equals 56. Then I can solve by adding 60 to both sides, and I see that y equals 116 for the y that's in the angle. Why don't you pause the video, take a look at the next couple of examples coming up, and see if you can figure those out. So let's see what you think. I see degrees in here for both of these expressions. So I know that these are angles. Well, what did we say about angles in the last one? We said opposite angles must be congruent. Opposite angles congruent. But are these angles that are opposite from each other? No, they're next to each other. So what do we remember about angles next to each other? Those are called the consecutive angles when they are right next to each other. That's right, they have to add up to 180 degrees. The consecutive angles are supplementary, meaning adding up to 180 degrees. So that's what we're going to do here to solve this one. Consecutive angles being supplementary, that's what we're using, the angles next to each other. So I'm going to say 5x minus 10 plus 12x minus 14, add those up, that makes 17x minus 24, and it has to be supplementary, so it has to equal 180. Now we can solve this equation. Adding 24 to both sides, 17x makes 204, and dividing by 17, 204 divided by 17, and we see x should be 12. How'd you do on the last one? Well, what is the last one labeling? I see k plus 10 pointing to this segment right here. It is inside the parallelogram, but I don't see any degrees symbols, so it's for this segment right here. Well, this segment is part of a diagonal, and this segment is part of a diagonal. So let's think back to what we know about diagonals. Take a quick glance at your properties in your notes. The diagonals bisect each other. Well, how does that help us? What does bisect mean? Bisect means cut in half. Bisect means cut in half. So this diagonal is cut into two pieces that are congruent. This diagonal is cut into two pieces that are congruent. Therefore, I can take the k expression and the other k expression, and they're supposed to be equal. So k plus 10 is supposed to equal 6k. If I subtract k from both sides, I get 10 equals 5k, and dividing by 5, I see that k must equal 2. Similarly, the 3j and the 5j minus 9 are both pieces of a diagonal that have been cut in half, so 5j minus 9 is to equal 3j. Let's get our j's together, so 2j and add 9 to the other side equals 9, so j equals 9 divided by 2, or 4.5. Okay, both of those answers quite acceptable. Feeling a little bit more comfortable with parallelograms? If not, maybe you rewind this section and go back and check it out.